Right, so next talk is from Johannes. And when I was reading the title, I was completely wrong about what the talk was about. And then I was reading the abstract again, and I was thinking like, hey, maybe this talk is about a friend of my wife, because he's doing kind of the work he's describing in the abstract. He's working with trees. But he's working in Germany. My friend works in the north of this country, so they're obviously not the same. But yeah, I'd love to hear your introduction to Postgres. Please take it away.
Well, I just wanted to share some thoughts on my way to Postgres, which was coming to me suddenly. I had my neighbor coming to ring on my door, and he just said, well, you work with computers, can you help me with a project? And so I asked him what it is about, and he told me, well, he works with trees. He visits about 4,000 trees every year, and he examines them regarding their health. Sorry.
No, you need to switch it here first, and then I'm going to switch it back then.
Okay. Yeah. Normally I have started it like this. Normally it works like this. So he goes to about 4,000 trees every year and checks about 100 attributes on each tree. And somehow this data ends up in a database. So his idea is, in Germany, everybody who works like him has such a database of some 1,000 trees. So why don't we make one large database with all of those trees? And the idea behind it is then to put that data on a map in the internet, so that everybody can look in his area how healthy which type of tree is in his area. So, for example, if in your area oak trees are dying, it might be a better idea to plant some different trees and not oak trees again, because they might be dead next year again. So that's the basic idea behind it. And his idea, of course, it should happen soon. It should work within 6 weeks, or 6 days would be better. And all of that with me doing it alone in my spare time, so not really happening. I told him I never designed a database before. I never created even a website before. I never wondered how to display geolocated data on a map, and didn't ask myself how to add any layers to it. So it would take longer. But since I've always been interested in ecological things, and since my kids are now both beyond 20, I thought I have a bit more time so I could give it a try. And then I started thinking about what could I use for it. And since trees don't move too much, I looked for a database system that can handle geolocated data. And that is how I found PostGIS, and through that then Postgres. So that's what I decided to use. And then the question was, how do I get the data into my database? And the idea was, I need to import CSV files. because he has his database, can export them. So how hard can it be? Well, it starts with, if I want to import it, he has to export it, but he has no clue how to do that. So he needs some support for that. He managed to do that, but something's wrong. There's so many semicolons. So then I finally had the CSV file, and maybe it would be easy to import it, but it was not. So let's look at some of the issues. You can see these are just the names of the trees. And it starts with that already because there's not a unique way of identifying trees. And we had to sit together for quite some time to get a list of names that we then want to use. But there are also issues with that, like you can see here species. Some nomenclations call it species, some call it spec, some call it spec dot, and the database has to know all of that is the same. Then I found a tree called Brücke, bridge in English. I said, what's that for a tree? And he says, it's not a tree, but it's a bridge that I need to find so that I can then find the tree behind it. So every tree that is called Brücke cannot be imported, and more things like that. Then he has comments in his data, and the comments sometimes include a whole address or an email address, phone number, whatever, so data that I cannot include for data protection reasons. So all of these need to be filtered out. Then there are at least 5 different systems that are used by people who work like him. And I got other CSV files where there was not even geolocated data, so I cannot import that at all. They first need to create a new way to export their data. So this is an example of the start of a CSV file, and I will show how I then went about, for example, the Deckungsart, which is one type to describe how the area around the tree is. So I create a search string where I say, search for the Deckungsart, and then I add the Deckungsart that I found in the CSV file. Then I check if that Deckungsart is already in my table Deckungsart. And if not, I try to insert it. And if it worked, everything's fine. If not, I say I could not insert it, so I need to debug later why it didn't work with this tree. Then I get my table with all the Deckungsarten that are in the table, and can then use them just through their ID and not have to put all the text, which can sometimes be very long, into my table where I store the data. Here are some two other examples, how the tree top is formed, or which type of grouping they have. So I come up with a table like this, where all the indices of my various tables are used. And here is also the geometry data. But there are so many projections. How should I import those data? Which ones should I use? So I looked and found, for example, that these can make a huge difference. If you look at Europe with a normal projection and with an Australian one, it doesn't really match. So choosing the right one seems to be important. And I settled for 4326, which seems to be the proper one for my area. So many people don't like pgadmin, but to view the geometry viewer, it is very useful. And I check where my trees are in Germany, and there's none, but here are some. So what happened? Let's look closer, even closer, and then switch Y and X, and we find them. So obviously they export latitude for longitude and longitude for latitude, which then creates the next problem because I told them so, and then they changed it. So now I have always to import data from before and data from afterwards to have the correct location. And as you can see with this tree here, the projection doesn't really seem to fit completely. So I'm still looking for a better way to adjust them so that the tree doesn't grow on the street. So now we have the data imported, and how can I display it correctly on a map, not just with the GeoViewer of PGAdmin. So I added GeoServer, and it looks something like this, where I can give the trees different styles depending on their health status. And if you click on any of the trees, you can get more information on that tree. Like here are some examples of free trees. And if you want historic data of one tree, you can also go back and see which data this tree had before. But in general, we only show the current data. So then the idea was we also want to know more about where the tree grows. So what do we add there? We add open layers so that we can add additional layers to it. Here are some examples of some layers that can be helpful, like weather, wind or precipitation, or how wet the soil is, how the temperatures are changing, and this gets put underneath the trees so that people can check whatever they want. Then the next question is, I want to be able to create any combination of those 100 attributes that I want. And I said, well, basically we could do that, but at least we should keep the geolocation in it so that we have less traffic and can narrow it down easier, because if you have any possible combination of 100 attributes, it is not easy to build indices that then work for every case that you have. The next thing was to keep all the data forever, which, as I said, we solved by keeping the current set in the database and moving each replaced data into a history table that can then be found through the tree itself, but not directly on the map. Then trace should be even faster, so more indexes created, the database partitioned, and I also am starting to create new tables where I have a table just for one specific attribute, like the tree has sunburn, and then I add in this table all the trees that have sunburn so that I can very quickly find all of them, because not many of the trees in the database have this specific topic, but it's often part of the queries. Then another idea was we should store images of the trees, but then we decided we won't store them directly in the database, but in a file system, and then store the location in the file system in the database to keep the database smaller. So that's it basically from me. If you have any questions, feel free.
Thank you very much. Amazing how much good decisions you can already make for such a small project. Well done. Pretty cool. So who can I help with questions?
I'm curious about size. How big is your database and how rapidly is it growing? Rows or gigabytes?
It's still in the beginning phase, but according to my neighbor, he estimates it will be for Germany about 2 billion trees. In Germany, it is recommended that every tree that grows next to a street or on a parking lot or wherever is monitored so that people who check the trees can assure that no branch will fall off and kill someone or something like that. Therefore, there are about 2 billion trees that are monitored at least once a year. 2 billion.
Just curious, why is this not a government initiative? Because in Holland there are cities that monitor their trees. So why is it? It sounds like it's done by individuals and not by government.
Each community employs someone who does it for this community. Therefore, each community has the data of those some 1,000 trees that someone checks there. And from that came the idea to combine all of those into one database. So basically the data is already there, but it's separated in many databases all across Germany.
Okay, do we have more questions?
Do you have many free text fields, and have you considered using full text indexes to search them?
There are many, but the content of them is not part of the queries. So if you look for a tree, there are about 90 attributes you can choose from, but the comments then come along with the tree data in total.
You started the presentation with the time you want to spend on this project, 6 weeks or 6 days. But how many years is it?
That's a good question. As I said, I'm still working on it, and I still don't have the final project that I could offer someone, because the idea basically is to create a prototype and then ask maybe the EU or anybody else who is interested in such an environmental project to fund it. But we are not at that stage yet, and I think once we get to that stage, the real work will only start. So it will be endless. Sure.
So you have your neighbor as one data provider. How many other data providers have you already been integrating? Is that a few? Is that a few hundred? Because you have 1,000 from your neighbor, and the estimate is a few billion.
Yes. At the moment, I have about 10, so roughly 50,000 trees. But I've also generated sets randomly so that I can test with larger numbers. But so far, we are still looking to get the prototype running so that we can then tell people, wouldn't you want to contribute your trees to the project as well?
All right, do we have one more question? Yes.
You said about the special tables with some kind of special attributes. Mm-hmm. Have you considered to use the index with where parameter? So where some attribute equals to whatever?
I haven't checked that in comparison to the tables, but I've had large improvement in query times when I used those special tables, but I can also give it a try with that. I'm still learning Postgres, and everything that might help there is always welcome. So if you have ideas, feel free to contact me. Other people also suggested it might be a good model to help training AI that tries to detect trees from satellite images, because if you know 2 billion trees in Germany are exactly this tree, it's much easier for them to learn how to spot them from the air.
Thank you. Do we have more questions? Asking once, asking twice. All right. Thank you very much.
Thank you.